Welcome, Stefan.
Hi. Thank you.
Have a seat.
Thank you.
Wow. So this is our partner slot, not only Siemens on display here, but also a lot of our partners who we work with, in this case, once again, On/Off GmbH. Nice to have you with us, Stefan. Digital twin, still a hot topic, but maybe you can tell us what you mean by that.
Yes. Oh, the digital twin is used in many different contexts. So somebody even sees that historical data of the plant is a digital twin, but we have a more holistic view on this topic. So we use the digital twin already during planning. So we can simulate in an early stage the behavior of the plant and can test and can identify some problems if there are any, or if there are needs of improvement. So what we can do, we can simulate months of production data in a few hours so that it's immense time saving and at least energy saving in this case.
Okay. So if we look at that, what's next? Do you have the presenter? You need the presenter, right? For your
I need
slides,
the presenter. Then
there we go.
Yeah. Okay.
All right. So if we once again look at the term digital planning, what happens next?
Yeah. After digital planning, we use the already modeled digital twin to go further with the engineering. So we use it if we are programming the PLCs, for example, with PCS7. We expand the model. We have all these modules in parallel for valves or machines, which fits together with the PLC program. So we expand the model and we go on with refining the model. And at the end, the model is so good that we could do an independent, plant-independent software commissioning.
So in the end, that means commissioning can be done without the real plant?
Yes, because we have already set up all in parallel during engineering and have a complete simulation situation so that we can simulate the complete behavior of the plant. And this massively shortens the time for the commissioning. So we can correct errors during virtual commissioning without damaging the plant, which is important. And at least in the end, the hardware tests have to be done with the real plant, of course. But if we then see that something doesn't work as expected, we know it's not the program's fault. There must be something different in the plant.
Okay. And another big advantage we have to emphasize here is the enormous time savings that you can achieve with digital twins, right?
Yes, of course. We have a reference project, and the plant owner told us that it's not minimizing the risk of damaging the plant during commissioning. They could carry out the operator training much earlier. We go live much sooner with the plant, with the real program. We could reduce the downtime. There was a planned downtime for 7 days for this plant, and at the end we could do it in 18 hours.
Oh wow,
that was really fast.
Talk about immense time savings, and through that also cost savings. So even after commissioning, the job of the digital twin is not done. It still continues, and it does a great job, right?
You can still use it because if you later want to change the process, want to produce another product or improve productivity, you can use the digital twin and test different situations and develop and test in advance. So there is no need to rebuild the complete plant for testing. You can do it with a digital twin. And another point is you can use it for troubleshooting. So if there appeared a trouble or a breakdown, you can import the historical data, the last historical data, the real data from the plant into the digital twin, and can have a look what happened shortly before the breakdown occurred. So it's a big help for the maintenance people. And you can, of course, train the operators with the digital twin and the maintenance stuff.
And I guess it's also applicable to already existing plants, right?
Yes, of course. So what we do with greenfield projects, we also can do with brownfield projects. So we can digitally map the existing plant to the digital twin. This is for increasing productivity or planning conversions, or even if there are software migrations planned, you can first test with the digital twin and then go on and go to real life.
But I can imagine simulating an existing plant is an immense effort. That is something else than a
No, not at all. We already developed a library We call it the on-off twin lib, twin library. So all components like valves and motors, pumps, and vessels they already exist in our library, and then we can stick them together like Lego bricks. And we are really flexible with this because if there are changes during planning, we just brick them together in another way, and it works again. So, and if sometimes there are new components we don't have in our library, but we can quickly build them on our existing structures.
Okay. And what if we talk about building, let's say, the virtual plant? Do you also build the real plant?
No. We at on-off, we don't build the real plant. That's done with planning companies together, or equipment manufacturers, or end customer at least. But what we do at on-off is we build and supply and install everything what's electrical. So beginning with the hardware planning, and then in our own workshop we build the control cabinets, and we are doing the wiring and installations and assembling on site and all this stuff. And afterwards we provide service and support and maintenance if it's needed.
Okay, and I have to ask, because we had the panel today on cybersecurity with our Chief Cybersecurity and Diversity Officer, Natalia Oropeza, this afternoon. What about cybersecurity in this context?
It's an important issue, of course. So all assets and subsystems we build and deliver, they will meet the needs of cybersecurity, because there are special needs for cybersecurity in OT networks. It's different from IT networks, and we do have our own specialists in cybersecurity, so they can support during planning and do the consulting during planning, and at the end we are implementing the secure solutions for this. So our roots are the automation technologies, so we know the needs of a plant, what is different to the IT systems, so the office IT, for example.
Okay.
So in this case, the digital twin helps as well, because you can test some changes in the network without disturbing the production.
So in the end, how does Siemens support in this context?
Yeah, that's good. There is a solution partner growth initiative at Siemens, and we were part of it. There were different workshops with Siemens and on-off, and Alexander Frisch, who was in the morning on the stage. And in these workshops, we defined digital business models, new digital business models for on-off. So it was a great help for us, these workshops. And so we have new business cases which we can use at on-off. So, and what to say, I'm really happy that we could be part of this great event here, and many thanks for that.